Hello everyone. So today we are going to be talking about the states of matter and the water cycle and how they interact. For this lecture, we are going to be talking about the three states of matter and their role in the water cycle. We are going to accurately define evaporation, condensation, precipitation, and transpiration. We are going to identify the places in Earth's system where water is collected throughout the water cycle. Make sure that you guys have your note guides ready and that you're following along with me and filling that out as we go. So the interesting thing about water is that it has three states of matter, and we see all of those naturally occurring states on the earth every single day. So when I see this picture, I think that that looks like ice, right? And so ice is water in its solid form. Then when we go to defining water in its intermediate phase, this phase looks like just regular water to me, but this is actually water in its liquid form. And so then when we look over at these arrows over here, we are going to talk about what is happening when we go from a solid to a liquid. So how would you describe that? We're going from ice to water. We would usually use the word melting, right? So melting requires an increase in energy to go from a solid to a liquid. So in this whole lecture, we're going to be talking about how we need differing, either need an increase of energy or a decrease of energy to change states of matter. So then we look at this arrow down here and we're going to ask about what is it called when we talk about going from a liquid to a solid. And I just flashed the picture there just to give you guys a little bit of a hint there, right? Does everyone have a freezer at their house? So when a liquid water goes to solid form, we call that freezing. And freezing requires a decrease in energy to go from a liquid to a solid state. So we filled out this half of our little diagram. So now we're going to look over here because there is one more state of matter that we have not talked about yet. And so when we see pictures of clouds, a lot of times we think of things in the atmosphere, but I want us today to think about water vapor when we see clouds because that's the easiest way to identify it, even though water vapor is all around us all the time. We're breathing in water vapor. But water vapor is water in its gas form. Okay, and so when we start looking at these arrows over here, these arrows have a few more, they're a little bit longer words and words that maybe we don't use on a daily basis. So we're going to cover them a little bit more closely because they're very important in the water cycle. So when we talk about water changing into water vapor, we use the word evaporation to describe this. So we're going to look at that a little bit more in depth. So evaporation, like I said already, is the process when liquid water turns into water vapor or gas. A liquid has to gain energy to become a gas. And so we've been talking about gaining energy and losing energy, but where are we getting this energy from? And so the answer to that is that the sun is responsible for energy, and it then heats up the water to cause evaporation to start happening. So the sun is the driving force of many of these changes. The increase or decrease in energy then is what affects temperature. So when we were younger, we talked more about the temperature changes, but now as we're getting older, we're talking about the energy changes necessary to change the temperature. And then this is what drives the changes between the states of matter. And since we're going to start talking a little bit more about these water changes in terms of naturally occurring water changes, I have this question down here, and it says, what causes water to freeze naturally? So take a minute to think about that and pause if you need time to think. But I'm going to move forward, and the answer is that we have less solar energy in the wintertime, and that is because the Earth is tilted away from the sun, which causes winter. So if you look, Pennsylvania would be right up around here, and in the wintertime we're not getting the direct sunlight, so therefore we're getting less solar energy, and because of less solar energy we have a decrease in temperature, and that's why we see more solid forms of water around our environment like snow and ice on those wonderful winter days. So another specific form of evaporation is transpiration, and we do need to talk about that it is a type of evaporation specific to plants, and it's the process of water moving throughout the plant and its evaporation occurring on the surface of the plant. So I really like this picture because it shows how water can be absorbed from the soil, and it's in its liquid form then, and it gets drawn up the stem. We all know that plants need water to survive. But then on the leaves, that is where the stomata are present, and that is where gas exchange happens. And so we see these nice little squiggly arrows, and that is representing that water has now turned from a liquid into a gas, and that is evaporation. But because it's coming directly from a plant, it's called transpiration. I also really like this picture because it has sunlight in it, and the arrows are pointing down, letting us know that the sunlight is acting on the plant, and it's the solar energy that's really causing this, because I wrote over here as my last note that this is a passive process requiring no energy from the plant. So it's not something that the plant is necessarily putting energy into. It's all energy coming from the sunlight there. Okay. So now we have almost our whole chart filled out. We're just missing one arrow over here. So what is it called when a gas or water vapor goes from gaseous form to a liquid form in the form of water? And that word is condensation. So we're going to talk about that a little bit more too. It is the process when water vapor or gas turns into liquid water. And so gas will have to lose energy to become a liquid. And we can see that here that it must be a nice humid day, and a humid day means that there's lots of water vapor in the air, and the water vapor is coming in contact with the cold glass, and it cools down and the droplets kind of bead together. And then we see actual liquid water forming on the outside of the glass here. Another specific thing that this is specifically condensation that happens in the atmosphere. It's called precipitation, and like I said, it happens when condensation is happening in the atmosphere. So clouds will form by water vapor condensing around dust particles in the atmosphere. If we didn't have dust particles in our atmosphere, we probably wouldn't have clouds quite the way we do right now. And precipitation can happen because of a change in energy, and sometimes we think about that in terms of temperature. And it can also happen when the atmosphere just becomes so saturated with water vapor, and that saturated just means that it cannot hold any more water vapor. So precipitation will happen in that case, as well as when water rich air, warm water rich air, or water vapor rich air it's warm down here closer to Earth, but then when it goes up higher into the atmosphere, it cools down, and then precipitation and condensation will happen that way as well. When the water drops condense together and it gets too heavy, eventually gravity is acting upon the water molecules and they fall back down to Earth. We know that there are different forms of precipitation, and we receive all of these here in Pennsylvania in the form of rain, and that is a liquid form, snow, which is a solid form, sleet, which is a mixture of liquid form and solid form, and then hail, which is pretty much just big chunks of ice falling down from the sky, and that can get a little bit dangerous. So these are different forms of precipitation, and they are caused by condensation. So now we have our states of matter diagram all filled out, and we need to talk about one more overarching concept, that the changes occur because of an increase or decrease in energy. So increasing energy and or temperature. So when we have a solid, we increase our energy by melting into a liquid, and then we increase our energy further through evaporation to turn into a gas. Then the opposite happens, that when we have gas and we decrease energy, we condensate, the gas condensates into a liquid, and then the liquid water, when we decrease energy additionally again, it freezes and it turns into a solid. So good idea to make sure you copy that down. It's in your note guide. Now we can finally move on to talking about more in depth about the water cycle. So the water cycle is the continuous circulation of water in the atmosphere. It's also called the hydrologic cycle. It explains where water is stored, and when we have a big area that is stored, that's called a collection location. And the water cycle explains how water moves. It moves in two ways, which is through solar energy, which we've talked about already, and we have a picture of our sun right here in the diagram, and through gravity. So we start off as a little water molecule here in the little pond, and evaporation happens because there's an increase in energy because of the sun's rays. The sun is also acting on the tree over here, resulting in transpiration of water vapor going up into the sky and condensating into liquid water. From there, gravity will act upon that heavier liquid water and come down to the earth as precipitation, and then the cycle can start again. Now, this is a very basic way to look at the water cycle, and we're going to look at it in a little bit more in-depth way that normally it just doesn't happen to that cycle, and a small little cycle, and a lot of times clouds move. So in this diagram, it talks about transportation of clouds that are able to transport water to other places that are nowhere near where the initial evaporation happened. So in this example, water is falling on, water is falling from the sky in the form of precipitation, and it looks like it's snow and rain, and it is falling down onto the mountain. And so then there are different collection sites that might happen as a result of it falling on the mountain. That we have water that will stay frozen up at the tops of mountains for a long time because it's typically colder there. And so water can stay there frozen for a long time. When it does start melting, we will have rivers transporting water, and that's another collection site. And these rivers will sometimes lead to the ocean, they will sometimes lead to a lake, and they will also sometimes percolate down through the soil and become groundwater to be used at a later date. So let's keep going. And I thought this water cycle picture showed or diagram showed a little bit better about the different water collection locations. So I think all of us know that oceans, lakes, and rivers are typical collection sites for water, but sometimes we don't think as much about water residing in soil for a long-term time, and that water also is in plants. And that's one of the reasons that rainforests have so much rain, is because of all the transpiration that's happening in the rainforest. The water vapor, the atmosphere just can't hold the water vapor. It's too oversaturated, and that's what causes so much rain in the rainforest. We also have water stored underground as groundwater. Sometimes these are called aquifers if they're big enough, and we like to access these waters by drilling down and using wells to get fresh water for ourselves. I talked a little bit about glaciers and water being stored frozen as ice. Most of our fresh water is frozen, and it's at either the South Pole or the North Pole. And then we have water storage in clouds, and we also have water storage in animals. And because we are animals, we are part of the water cycle too. When we drink water, we are actually 70% water, so we're a big storage site for water in the water cycle, and eventually we will excrete that water in the form of pee, and that water will eventually be reused again and again. So just to wrap it up, these were all important things for us to know for class tomorrow. Tomorrow we will be participating in the water cycle simulation, so I hope you guys are ready for that, and your notes will be due at the beginning of class. I hope that you were following along with me that entire time. I hope you guys are ready to have fun tomorrow. Have a good night. Bye.